student, and this is a numerical of electromagnetic induction. It's a very nice numerical. There are so many things to discuss. So first of all, let us see the numerical properly. What is said? A long solenoid whose diameter is given and having a particular turns per meter. At the center of the solenoid, a coil of this much of turn and radius is placed with its axis coinciding with the solenoid of the axis, and current in the solenoid reduces that at a constant rate of this much. If resistance of the coil is 10 pi square ohm, then total charge flowing through the coil during this time. Actually, what is said in the numerical, so let us first, let us draw a diagram, little bit of diagram to get the idea. So if there is a solenoid like this, there is a solenoid, and this is the solenoid, this is the solenoid. My diagram is really very bad, and this is the axis of the solenoid, and through the solenoid current is flowing, and due to which we will have a magnetic field, which is, all of you know, that is this magnetic field B is equal to mu naught Ni. This is okay. Then said in the question that you put a coil like this such that axis of the coil is along the axis of the solenoid, and when current to the solenoid changes, that means this I changes, so definitely B will also changes, so that will make a change in the magnetic flux. Okay, now if we see the Faraday's law, we are getting that E is equal to what? E is equal to our d phi by dt, you know that. And again by Ohm's law, E is equal to what? E is equal to I into R. Okay. Then again for I can write del Q by del T divided, del Q by del T into what? R. So if you cancel del T, so what you can write? You can write that dq is equal to del phi by R. So this is the formula on which you have to make your calculation, and you have to collect the data from the given problem. So this is the main formula. Okay. So that means in order to find out the charge, you have to find out how the magnetic flux will change. So let us do it. Okay. Now you see what will be del phi. So what will be del phi? What will be del phi? You know that del phi can be written as what? Del B into A. Okay. So B is the magnetic field due to solenoid. So that is actually what? Mu naught Ni, and into A, that is A is the area of this coil. So that is number of turns in the coil into pi R square. That is, what is R? R is the radius of this coil. Okay, so here del is fitted with this current. You see here, because what is given, the current is changing at constant rate from 0 ampere to 4 ampere in this much of seconds. So that's why, so del will be with I, then mu naught, then N, then capital N, then pi, and then R square. So this is your del phi. This is your del phi, and whenever you divide it by R, you will have your result. Now here del I will be how much? Del I is equal to 4 minus 0, that is 4. So write down the value of mu naught, that is what? 4 pi into 10 to the power minus 7. Small n is the number of turns of the solenoid, that is number of turns per unit meter, that is small n, and which is given as 2 into 10 to the power 4. So here you write 2 into 10 to the power 4 into capital N, which is the turn in the coil inside the solenoid, which is given as 100, Then once again you write for area, this is pi, and radius of the coil is 0 point, this is the radius of the coil. The radius of the coil is this one, 0.1 meter. So that is 10 to the power minus 2 whole square divided by the resistance of the coil, which is this one, which is already given there. This is, which is 10 pi square, which is 10 pi square. So on putting the value, now you do the calculation, and if you do the calculation by putting the values, and then it will comes out to be 32 microcoulomb. So that means this is your answer. Thank you.